Okay, we're going to go ahead and get started with this problem. This gives us a nice summary of the first section in chapter 5, integrals, antiderivatives. Basically, I gave you a little plethora of problems to kind of see where we're at. And the idea is, if you can do the first one, you could do all of them. Where people get tripped up on is the same old issues: fractions, decimals, negatives, blah, blah, blah. There's only a couple special cases. So to me, the big advice is be careful, but we have to understand what we're doing. What we're doing is taking the antiderivative, the integral, the opposite of derivatives. And just like we do with derivatives, if you can rewrite it first to make it easier, I would totally do that. So the first thing I'm going to do is rewrite it. X to the 7, no problem. 3x to the 5th, no problem. Minus 2/3 x to the 1/4, no problem. Plus 0.4 x to the 0.3, no problem. And then this one I'd rewrite as minus 4 x to the 2/3. So if you're not sure how to rewrite it, that's the issue. It's not the calculus, it's not algebra, it's being able to rewrite it, right? Knowing how to rewrite it. Same thing with the next one. I would put minus 7x to the negative 2, minus 5x to the negative 1, plus 6 e to the x, minus 2x plus 10. And remember, when you have an integral, at the end, we'll have a dx or dt, whatever the variable is. They go together. But once you take the integral, they both disappear. So step 1, rewrite it. So step 1 was to rewrite it. Step 2 is to take the integral. Now, I don't want to oversimplify it, but how do we take an integral? Well, we add 1 to the exponent and we divide it. That's it. If you can do the first one, you can do all the rest. There's only a couple special cases, but if you can do the first one, you can do the rest. So the next one, the 3 stays in front, add 1 to the exponent and divide by it. The negative 2/3 stays in front, add 1 and divide by it. And this is where the mistakes happen. 1/4 plus 1, that could be 5/4. That could be 1.25. Decimals or fractions is fine. And if you're struggling with decimals and fractions, you can use your calculator. I'm not going to do this for all of them, but just to remind you, 1/4 plus 1 is 1.25, or math fraction 5/4. So again, with a calculator, there really is no excuses. I'm going to do it as a fraction. So it'll be 5/4 divided by 5/4. But if you did 1.5, 1.25, same thing. The 0.4 stays, add 1, 1.3 divided by 1.3. The minus 4 stays in. Again, 2/3 plus 1 is going to be 5/3. If you need the calculator, use the calculator and divide by 5/3. Minus 7. Now, as soon as we see a negative, you're like, special case. Not true. Negatives are fine. The only special case is negative 1. And we'll talk about that in a minute. Negative 2 is no problem. Add 1, you get negative 1, divide by negative 1. It's just like all the rest. And then the minus 5. But yes, x to the negative 1, or 1 over x, is a special case. Why is it a special case? If you added 1, you get 0. That's not the problem. The next step is the problem. You can't divide by 0. Right? So that's one we're going to have to remember, is the integral of x to the negative 1 is ln absolute value of x. And if you're like, how do we know that? When we did special case derivatives, the derivative of ln of x was 1 over x, right? The absolute value just makes sure that we can take the log of it. And then plus 6, the integral of e to the x is e to the x, minus, this is x to the 1, 2x to the 1, so the 2 stays. That's x2 over 2. And then what's the integral of 10? 10x. Now, we had a whole conversation about this last class. At the end of every integral, what should you have? Plus c for the variable, that the number, the constant that could have been there, or the constant that could have been there. Are we okay? Now, I'm going to pause there because that means you know how to take the integral, but can you simplify it? So I'll give you a minute there. Simplifying may be the issue, not the calculus. Yes, what you have is a correct answer, but it's not simplified. It can be simplified. It could be rewritten so it's a little bit easier. So for example, 8x, x to the 8 over 8, I would rewrite that as 1 over 8, x to the 8. It's the same, just looks a little bit cleaner. I wouldn't mark it wrong the other way. But 3 over 6, that simplifies to 1/2 x to the 6. Now, minus, 2/3 divided by 5/4. Well, that's 8 over 15. And you're like, how did he get that? Well, I know fractions, or you can use your calculator. It's 2/3. It's 2/3 divided by 5/4. And that gives you 0.5333 repeating, or math fraction 8 over 15. So again, your issue may not be anything to do with calculus. It could be issues with fractions. So that's 8 over 15, x to the 5/4, plus 0.4 divided by 1.3, 0.4 divided by 1.3. That gives you that weird number. But if we do math, fraction, we get 4 over 13. Again, this is not meant to be more work. This is meant to be simplified. That means it looks simpler when we're done. So we have 4 divided by 5/3, which is 12 over 5. But again, if you want to use the calculator, 4 divided by 5/3. Enter, you can put 2.4, or math fraction 12 over 5. X to the 5/3. -7 divided by -1 is +7. X to the 1, I'd move to the bottom. Minus 5 ln absolute value of x, plus 6 e to the x. Minus 2 divided by 2 is 1, so you had x squared, plus 10x plus c. To me, that would be your final simplified answer. Final simplified answer. So we just completed section 5.1, which are integrals. Now we're going to deal with integrals that are a little harder. And before with derivatives, we had a product rule, we had quotient rule, we had chain rule, we had all these techniques. We don't have those techniques for integral, but one of the techniques we do have is something called U substitution. And I want you to think of U substitution as a little game, but you have to know how the game works in order to use it. But the basic idea of U substitution is it starts hard. And with the right substitutions, it becomes easier. With the right substitutions, it becomes easier. The wrong substitutions doesn't work. You got to have the right substitutions. And by the end, you're like, oh, I've made it so much easier. Okay. So to be honest, I'm just going to kind of do one and we're going to walk through it. It's not going to make total sense. It's going to take a little bit to get there, but let me just lay it all out there of the why and the how and all that. And then in practice, you'll start seeing the patterns and you'll start seeing how this works. Okay. So here's your first example. And I want you to answer one simple question. Does this look like an easier one or a harder one? Just to look at it. What do you think? It looks harder. Why does it look harder? I don't have a series of terms that I'm taking the integral of each one. I got two things being multiplied. Not only do I have two things being multiplied, I got stuff that's cubed. This is definitely a harder one. This is not something I'm going to add one and divide by it. It's harder. So as soon as you identify that this isn't a basic integral, we got some work to do. The one strategy that you have is called U substitution. Now, I'm going to do it. I'll explain it as I go, but it's not going to click until we're done. It's not going to click until we do some examples. So we agree that right now, this is a harder one. My job is to make it an easier one. And to do that, we're going to turn something into U. Now, this is where the trick, the magic happens. And you'll get better at it with more examples. But here's the trick. I'm going to have to pick something that when I manipulate it, it will become easier at the end. So what is my U going to be? Now, I'm going to tell you that U is x to the 5th minus 2. And you'll be like, how did he know that? And the answer is, I'm a genius. No, the answer is, I've done a bunch of these, so I know, and you will know too with practice. But bottom line, you pick something to be your U. Now, this is where it gets a little weird. After you pick that U, whatever it is, it could be the inside, it could be the outside, it could be the other one, it could be the, whatever you want U to be, but only one U will work. Only one U will work. My U is x to the 5th minus 2. After you pick whatever that U is, you're going to take the derivative of U with respect to x. Now that sounds fancy, but bottom line, after you take the U, you're going to take the derivative of it. So what's the derivative of x to the 5th? 5x to the 4. And what's the derivative of minus 2? 0. Perfect. So step 1, pick your U. We'll practice that soon. Step 2, take the derivative of U with respect to x. Now, again, it will make more sense later. We need to solve for dx. So how do I do that? A little bit of algebra. We're going to cross multiply. Dx times 5x to the 4 equals du times 1. And if I want du by itself, I'm going to divide by 5x to the 4, divide by 5x to the 4, and we're going to get dx equals du over 5x to the 4. Now, that little bit of algebra, I kind of walked through to show you how I got from this to this. Dx equals du over 5x to the 4. I'm not going to show that algebra every single time. I'll do it 1 or 2 more times because it's the same algebra. It will always be. So I'm going to avoid this algebra because I already know what's going to happen. It's always going to change to dx equals du over 5x to the 4. Now, I'm going to use this u and I'm going to use this dx to now make my problem from a hard problem, a more complicated problem, to an easier problem. How am I going to do that? Well, here's the problem. The integral of x to the 5th minus 2 raised to the 3rd times 5x to the 4 dx. Right now, I have no idea what to do. 2 things being multiplied. I got something cubed. How am I supposed to deal with this? So I'm going to make my substitutions. Instead of x to the 5th minus 2, I'm going to change that to u. So right away, does that make my life a little easier? Yeah, I don't have x to the 5th minus 2 cubed. Now I just have u cubed. That's a lot easier. So number 1, it's making my life a little easier. I don't have anything for 5x to the 4, but instead of dx, dx is du over 5x to the 4. So instead of x to the 5th minus 2, that became u. Instead of dx, that became du over 5x to the 4. Now, you're looking at this, and initially you're saying, wait a minute, you made something complicated more complicated. You used to have x, now you have x's and u's, you've just made it harder. But if you take a second look, at this, what ends up happening? Anybody see it? Do you see anything at all? 5x to the 4 divided by 5x to the 4 is what? 1. So what are you left with now? I'm left with the integral of u to the 3rd du. Instead of in terms of x, I'm now in terms of u, and it is much simpler than it was. Now, please understand, have we taken the integral yet? We have not taken the integral yet. All I've done is made the substitutions, so now I can take the integral. What's the integral of u to the 3rd? U to the 4 over 4. Don't forget your plus c. Now, part of you are saying, I don't think that's done. And you're right, it's not done. Because do I want my final answer with a u in it? No. So the very last step, instead of u, what is u? U is, and you can say u is in math, can't say it in English, but u is x to the 5th minus 2 raised to the 4 over 4 plus c, final answer. Take a minute, look at it. So normally the big first question is, how did you know what u is? And my answer simply is, number one, u should make your life easier. So when I changed x to the 5th minus 2 to u, and it's only u cubed, that made my life easier. And then number two, I know I'm going to take the derivative of it. The derivative is 5x to the 4. Hey, there's a 5x to the 4 there. It ends up on the bottom. It's going to simplify. That's another clue. So number one, it makes your original easier, and the derivative makes it easier. Okay, so what we need to do, practice, 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 and it will make more sense. So here's another example. Your next example is we're going to have the integral of x squared plus 2x plus 5 raised to the 7 times 2x plus 2 dx. Okay, so let's write it down first. First of all, is this an easier, and I hate to use the word easy and hard, but is this an easier one or a harder one? Harder one. I got two things being multiplied. I got stuff raised to the 7. It's not add 1 and divide by it. It's a harder one. So if it's a harder one, we're going to have to pick u. Now, just guess. Don't move on. Just pick u and go from, and just stop. Just take a guess. If you had to pick, what is u going to be? Don't say it out loud. Just a couple seconds. Take a wild guess. If you had to pick what u is, and u could be anything you want, but only one u is going to work. Just take a guess. Don't say it out loud. You don't even have to write it down if you don't want. But it's that, what could u be? Okay? U is going to be x squared plus 2x plus 5. Now, how do I know that? Because I'm a genius. And I've done a million of these. And soon you will be too. First of all of this is being raised to the 7. If that was a u, would that make my life easier? Absolutely. Step 2, the derivative of u with respect to x. Now, we do have to show all of our work in the beginning to make sure we understand. Basically, we're taking the derivative. The derivative is going to be 2x plus 2. How convenient. If you look at your problem, what also do we have? 2x plus 2. So that's a big clue that I'm on the right direction. Okay? Then, this is the last time I'm going to do the algebra. We'll do the shortcut from this point on. The algebra is, this is over 1. We want to solve for dx, so we cross multiply. Dx times 2x plus 2 equals du times 1, which is du. We want to get dx by itself, so we divide by 2x plus 1. We divide by 2x plus 1, and you end up with dx equals du over 2x plus 1. Now, the reason why I'm not going to do that algebra again is because it's always the same. It's always going to end up being dx equals du over 2x plus 1. Okay? Now, I'm going to do the substitution. I'm going to pause and see if you can finish it from then. So, instead of x squared plus 2x plus 5, that's going to become u raised to the 7. I'm going to bring down the 2x plus 2. And instead of dx, that's du over 2x plus 2. I'm going to pause there and just give you some time to finish it. Give it a try. Only the second example. Give it a try. So, notice we can simplify 2x plus 1 over 2x plus 1 is 1. We haven't taken the integral yet, but we're left with u to the 7 du. So what we did was, with u substitution, we're able to make something that was hard into something much simpler. But I haven't taken the integral yet. When you take the integral, this will be u8 over 8. Don't forget the plus c. And when you take the integral and the du both go away. We don't want our final answer in terms of u. So the very last step is, instead of u, we go back and put what u is x squared plus 2x plus 5 raised to the 8 over 8 plus c. Okay. So notice each time I'm kind of guiding you through. Now I'm not going to guide you through. I'm going to give you one to try on your own. Like the ones we've done before, I'm going to give you a good head start. See what you can do with it. And then we're going to keep practicing and practicing. And my hope is eventually it will click. Eventually it will click. So again, for this one, it's a more complicated one. We're going to do U substitution. See if you can figure out the U. See if you can take it all the way on your own. Again, right or wrong, just give it a try. Try to get used to the process. And we're just going to keep practicing. Okay, so here, again, anything can be U, but only one U is going to work. The correct U is going to be x to the third minus 5. When you take the derivative of U with respect to x, you get the 3x squared. There's a clue, 3x squared, 3x squared. Again, I'm not going to do the algebra because it's always going to end up being dx equals du over 3x squared. We know we're on the right track. So when I do the substitutions carefully, this is going to be u to the 4 times 3x squared. Dx is du over 3x squared. 3x squared over 3x squared turns to 1. We haven't taken the integral. U to the 4 du. Don't forget, that's just cleaning it up. That's just simplifying it. That's just a substitution. Now we have to take the integral. U to the 5th over 5 plus c. And u is x to the 3rd minus 5 raised to the 5th over 5 plus c, which can also be written as 1/5 x to the 3rd minus 5 raised to the 5 plus c. Either one's correct. Either one is correct. Now, here's another one. I'm going to say we're not stepping it up at all. But you're going to think, oh, we're stepping it up. And here's why. The next one is going to be x squared plus 5 raised to the 1/2 times 2x dx. You're going to say, oh, you've made it harder. Why? There's a fraction. It doesn't change anything, but some of you see a fraction and that's the problem. But it's the same idea. So give this one a try. Don't let the fraction bother you. This is the same level, same everything. Don't let the fraction bother you. So same process. You're going to determine what u is going to be. U is going to be x squared plus 5. The derivative of u with respect to x is 2x. It's going to end up being dx equals du over 2x. Notice I'm going a little faster because we're getting used to how the game's played, how everything moves. When I do the substitutions, this is going to be u to the 1/2, 2x, dx is du over 2x, 2x over 2x. We're left with the integral of u to the 1/2 du. I'm going to pause there because for u substitution, everything's the same. But we're left with a fraction. It's a fraction. Who cares? It's just another number, right? But the process is all the same. Just be careful. I haven't taken the integral yet. Now, I'm going to do this both ways, not to confuse you, but just there really is two ways. If you want to do it as a decimal, this will be u to the 1.5 over 1.5 plus c, no problem. Or as a fraction, u to the 3 over 2 over 3 over 2 plus c. Same thing, same thing. Don't let the fraction decimal thing throw you off. Now, if I was going to simplify this, this would be 1 divided by 1.5. So 1 divided by 1.5, 1 divided by 1.5 gives you 0.6 repeating, math, fraction. That ends up being 2/3. So it's a little bit easier to say 2/3. And instead of u, I'm going to go back to x squared plus 5 raised to the 1.5 plus c. Or this is 1 divided by 3 over 2. Well, 1 divided by 3 over 2. That repeating 0.66666. Math, fraction, 2/3. So either way, you're going to end up with the same answer. 2/3 x squared plus 5 raised to the 3/2 plus c. So either way, either way, either way. So let's keep practicing. Let's keep doing more. It's the same thing, but this one has one little thing that shouldn't throw us off, but may throw us off. And that's why I want to give this a try. Okay. So again, I'm going to give you the hint that it's U substitution. It's a more complicated one, but it's the same stuff. But one little thing that's going to happen along the way, let's see if that throws you off or not. So the more we do, the better we get, the more practice, the more we build our confidence, the more experience we have. This one has a little something that happens along the way. Now, that little something is U is going to be x cubed minus 5. Again, you may pick a wrong U. It may not work. You just have to start again. It happens. But that number one makes my life easier. And number two, when you take the derivative, you get 3x squared. X squared, x squared. There's a 3 there. We'll talk about that. So when we solve for dx, we get dx equals du over 3x squared. So let me do the substitutions, then we'll pause. So we're going to take the integral. This will be u to the 4 x squared du over 3x squared. Now, be careful. Number one, we know that x squared over x squared is 1. But we're left with the 3. Now be careful. Is it a 3 or is it a 1/3? Good, because it's on the bottom, this is actually integral of 1/3 u to the 4 du. Okay, I'll pause there. Remember, in this process, we have not taken the integral yet. This is just to clean up. This is just to simplify. This is just use substitution. Now, the 1/3 stays in front. Add 1, divide by it. Don't forget your plus c. And then don't let the fractions bother you. This is 3 times 5. That's 1 over 15. Instead of u, we have x to the 3rd minus 5 raised to the 5th plus c. That would be your final simplified answer. At this point, you're all intelligent people. You're saying, I got this. I don't know why he makes a big deal, because the u is always what's inside the parentheses. The u is always what's inside the parentheses. The u is always what's inside the parentheses. The u has always been what's inside the parentheses. So I don't even have to even think about it. It's what's inside the parentheses. Fantastic. Until this problem. It's not always what's inside the parentheses. For example, here's a problem. The integral of x squared e to the 4x to the 3rd dx. There's no parenthesis. It's not always what's inside the parentheses, but I can tell you it's always what number 1 makes it easier. Number 2, the derivative makes it easier. That's still the same. Okay, so we can't always say it's what's inside the parentheses, but I can tell you it's whatever makes the original easier, and then the derivative makes it even easier. So give it a try. Give it a try. Here, it's a little tougher to figure out. There's no parentheses, but here's the thinking. Let's say you chose x squared to be your u. When you take the derivative of u with respect to x, you get 2x. Is that 2x going to help me with 4x to the 3rd? No. And I don't know how to take the e of something. I know e to the x is e to the x, but I don't know e to the 4x cubed. All of that is leading you to think that u is going to be 4x to the 3rd. Why? It becomes e to the u much simpler. And the derivative is 12x squared, x squared, x squared. See how those clues are leading you to the correct one. Okay? Now, I'm not saying we're done by any means, but the u is going to be 4x to the 3rd. Why? It makes my life easier. Instead of e to the 4x to the third, I'm going to make it e to the u. Now, again, you could have made all of that u, but then taking the derivative of that would have been more complicated. The whole thing would have been more complicated. It just doesn't work, right? Then this is going to be dx equals du over 12x squared. So this is going to be the integral of x squared du over 12x squared. I'm going to pause there and let you finish that off. So as we do these over and over again, we're getting a little faster, but still don't lose the point. X squared over x squared is 1. We haven't taken the integral yet. Please remember that. A lot of times people will just add a plus c and move on. You haven't taken the integral in an integral problem. We're left with 1 over 12. 12's in the denominator, not in the numerator. E to the u du. Now we still have to take the integral. So the 1 over 12 stays in front. The integral of e to the u is e to the u. Don't forget your plus c. And then instead of u, we put 1 over 12 e to the 4x to the third plus c. And again, the more we do, the better we get at it, more we're exposed to, we understand it hopefully better.